All right, welcome to Friday. 2.4. We're finishing up homework for the video. Gotta do it, and then handing back your exam ones. We'll see what we're gonna do with those. And then I have a schedule to give to you guys. Actually, yeah, I'll wait for the schedule for the other three to come back. So 2.4. Let's continue as fast as we can. Number 17. Who needed number 17? Raise your hand if you needed number 17. Okay, cool. This is 2.4. So we have a boat leaves the harbor entrance and travels 25 miles in the direction of, north and east. So the ground has to be here if they're from a harbor. So it goes this way, and it's 42 degrees northeast. The captain then turns the ship 90 degrees. Okay, captain. Travels another 18 miles in direction this way. So south 48 degrees east. So it says there was a right triangle here. You guys verify, is that a right triangle or no? Just want to make sure. Yeah, okay. At the time, how far is the boat away from the harbor entrance, and what is the bearing of the boat from the harbor entrance? So I'm not sure. I think it's kind of like somewhere over here, like this. I don't know. Maybe just erase this one just a little bit here. Because it traveled less miles, right? So maybe like about like this. It's 25 compared to 18. So I'm thinking something along that line right there.
What is the S? It says
south 48 east. Okay. So 25 is here, 18 is here. And I think we can get the hypotenuse just by Pythagorean theorem, is that right? Is that the easy one? I think that's the easy one. And so anybody do that for me real quick here. 25 plus 18 squared is equal to c squared. And go from there. Da, 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 da. Haley?
949.
See again?
949.
949, and that's 31. Perfect. Okay. 31, that's cool. And now the fun part is getting our angle measurement. So we're sitting in a triangle. We are in a right triangle, and we're looking at this right here. So I think I'm going to get the inside angle. We're good? Of the triangle. And Matthias agrees. We're good. Okay, talk to me. What should we do? What is that? Which trig function gives me those numbers? We don't want to use the 31 because that's an approximation, right? We want to use the original ones. Sine, cosine, or tangent. So let's see, we have the right triangle is right here. We just figured out our hypotenuse. That's what we did over here. So I'm looking at this angle. I'm looking at opposite side and adjacent side. It's tangent. As soon as we say that. Tangent of I don't know is equal to opposite over adjacent. So anybody again with this one here gets me tangent inverse. Sorry, that chicken scratch means tangent inverse. 18 over 25. Anybody with those numbers? Or if you did the homework, just give me the answer.
35.8.
35.8. So I'm going to just go 36, round off that, okay? Since it seems like all the others. Can I get a second on that? Second on that? Cool. All right, so now I have this. Notice the ship was going up already north and then it went east, right? So this little 36 has to then be added with that little 42 together. We good there? I'm thinking 78 degrees, would that work? So now I'm going with north 78 degrees east. That's where we're at. The original 42 when the boat left the harbor direction it was going. Cool. All right, 17 is good. Out in the middle of the ocean, though they don't do it this way, they have to move off of the right triangle because there's not like, wow, great, right triangles. Both don't normally turn 90 degrees, right? And so if they turn 40 degrees or 20 degrees, you have to get, so we're gonna get into loft sines and cosines. And this is so cool. In the ocean, there are different stream patterns, right? So boats take those as well. Just like airplanes, when the airplanes fly, they take jet streams up in the air. They'll take that one because it allows them to cruise faster, less fuel and all that good stuff here. So we'll take those two, that's cool. All right, 49. Do we have 49? Hold on, can't be. This section doesn't have 49. 29. Okay. All right, 29, rotation of the Earth. Let's go for it here. What do I have us? I have Earth itself. Satellite circling 112 miles above the Earth. Here's my little satellite. And that I know is 112. Above the Earth is shown in figure. When the satellite is directly above ground B, angle A goes all the way to the end right over here, is found to be 76.6 degrees. Use the information to find the radius of the Earth. Okay, so we're going backwards here. We need to figure out what in the world is R. How do we find the radius of the Earth based upon a satellite? Eratosthenes, which is the first person to measure the Earth, he was actually pretty close. And he did it by the, kind of almost the same thing. He did it by angle of the sun. So he did. Okay. So I think there's a little bit of an assumption here. Assumption is this right here is a right triangle. So right there, there's my little right triangle here. I have that. A little bit of a complicated problem. I think we can do it. Anybody have any suggestions?
I did sine 76.6 equals R divided by 112.
R, so opposite side, divided by hypotenuse, and R plus 112. Is that perfect? Good job. That is perfect. Right there. So the setup is, I don't know what this is at all. I have no clue. I just know it's hovering 112 miles above the Earth. Therefore, I have an R value here. All my variables that I don't know, at least I can write them down. So the only question I have from this angle point of view, I know the opposite side, and I have the hypotenuse that I have relationships with. So that definitely would be sine. Okay, a little bit of work here. Let's multiply both sides by R plus 112. R plus 112, canceled. And we're going to distribute the sine 76.6 to the R, distribute it to the other one, which is 112. 6, and then we have R just by itself. Is that right? All right, talk to me, anybody. And I'm teaching that to the algebra class because whenever you see variables, the concentration is to get the variables on one side. That's what usually is going to be, especially in higher mathematics. That's what's going to be important. Because once you get variables on one side together, the rest should be somewhat easier. All right, and then we factor out the R. All right, guys, doing good? Yes, and then you can add your name to this little pole, this little piece right there. All right. Zechariah, you guys remeasured the pole?
Yeah.
Did you guys get a slightly different number now?
Yeah.
Okay. Closer, you think, or more air?
Probably closer.
Okay. Cool, thank you so much.
Yeah, I think we did it completely wrong this time.
100% incorrect.
Yeah. For cats, especially. So she won't know how to do it. That's what the goal is.
Did you thoroughly confuse her? Okay, we are finishing up 2.429 on the homework here. So I got this, dividing by this. Da, da, da. I got here. Okay, and then so I need this one in the calculator. It's 112 times sine of 76.6 divided by 1 minus sine of 76.6. We're getting into some pretty cool math over here. All right, as you punch it in a calculator, just a few things you got to be mindful of. On top, because it's a numerator, you don't have to really be mindful of the parentheses. But on the bottom, when you put this little divide sign in, you have to put an extra parenthesis to sort of keep all that denominator in itself. And then you get another parenthesis for the sign itself. So at the end, you should have two parentheses or closing. We're good? As you punch it in. And real quick here, guys, we're here. You guys are in school. Ask me the questions if you have them, right? So that's the whole point.
Right under the large drawing where it's got the equation, is it R minus P side?
Right here?
I can't know what that is.
Sorry. This one right here?
Yeah.
It's just R minus R
Oh,
sign
okay.
as I move the R over. Yes, please ask me the question. Ask me if you're confused. If you're confused about my chicken scratch. That's cool too. All right, I need an answer of anybody that's got it.
I have 4,001.99.
4,000. 4,000.19.
Or no, 4,001, sorry.
4,001.
And then point 992.
Okay. Okay, so 4,002. Let's see. Anybody got something else? Anybody know what the answer is to number 29?
4,000.
Yeah, it is 4,000. Okay, rounded. Okay, I'm gonna go with it. I'm thinking about circumference. That's what I'm thinking about. Okay, circumference there as opposed to radius. And I'm thinking about miles in here, right? So 4,000 miles roughly is the radius of the Earth. Cool. Okay, 2.4, are we good? 2.5, if I can find them. It was up here, that's right. 9 and 33. Finally, done. When are we out of here, guys? 9:45? Yeah, 45 minute classes here. Okay. 2.5, almost done. 2.5 is 9 bearing of some hot air balloons. Anybody ever went up on a hot air balloon before? No one's going twice? No. When I used to live in Fresno, they used to have every year in October, they had a flyover by hot air balloons. So you'd wake up on a Saturday morning, and you'd have like 20 hot air balloons really above your house and stuff. So they go from the airport to another little landing in Madera. It was kind of fun little thing to see those. And you usually wake up to this sound of as they're putting fire to the upper chamber of the balloon here. That was neat though. Very colorful, especially if it's right above your house. Okay, we got hot air balloons. 1 and 2. I think I'm drawing it correctly here. Okay, what's the movie about the hot air balloon? The person that was it?
Oh, yeah. I don't remember what it's called.
Probably not.
Say again?
No, you're probably not thinking about it, right?
No.
Think about the first instrumental
Oh, yeah, no.
pressure gauge. Let's see, first measuring of the atmosphere.
Oh,
Up to space.
aeronauts. Is that what you're-
Aeronauts? I think that's what.
Like
Yeah.
Red Main and Force Speed.
Yes, correct. That was cool. Okay, raise your hand. You watched it. Cool. If you didn't raise your hand, you probably should. It's pretty cool. It was cool.
I was gonna die the whole time. That was the only thing that happened the entire time. They were just gonna die.
They're just gonna die.
Yeah.
The preseason game.
So a person riding on a hot air balloon, hopefully not going to space and dying. For the first hour, the wind current is a constant. So let's real quick here. Let me get the diagram here. 9.5 miles per hour in the direction of that direction. Okay, so we go this way up. So 37 point, no chicken scratch here, 37.5. Hey, this is very similar to what we just did on the previous one here. Then the wind current changes to 8 miles per hour and heads the balloon in the direction of South 52 east. Okay, so we go this way now. I think I see a little pattern here. This is 52.5. If it continues to another 1.5 hours, how far is the balloon from its starting point? Ooh, so I think we're trying to judge this distance here, right? Okay, so first things first, do we have ourselves a 90-degree triangle? I think so, yeah, it's the addition of this one and this one. So that I can say that this is a 90-degree piece there. And so for the first hour, we're going at 9.5 miles per hour. Then the wind changes to 8 miles per hour and heads the balloon in the direction of, and then this speed of 8 miles per hour is continued for 1.5. So anybody 8 times 1.5 first, because we need to know our distances. 12 is good, okay. So how far is it from the starting point? What's the bearing of the balloon? Are we good? Is this the exact same problem as the boat on the water problem? Yes, very much. Okay, Pythagorean theorem, go for it. I need a 9.5 squared plus 12 squared added up and give me a square root. So 9.5 squared plus 12 squared, c squared at this point. Anybody give me that one? Thank you. Sure, no problem. 15.3, can I get a second on that? Cool, okay. Got that one, and now the bearing. Again, same as the boat problem from last time here. I go this, which is opposite, and adjacent is what I'm looking at. So tangent of theta is going to be the opposite. Tangent inverse, make sure you are in degree mode. And what do we have for theta? Six three. So I'm going to go with 51.6 just because the other angles are to the nearest tenth. Anybody second that? Cool. All right, and I think I have this. I think I have a 37.5 original that we started with plus this right here. All right, so I want to include this big angle right here now. It's this wide angle there. So I know I'm still going north.
So you add those two angles up together.
Mm-hmm. Let's see, just kind of thinking just a bit here. Yeah, because it would have been 80, and it's close too. It's almost close to 90, right? Because if it was, let's say this angle was like 60, and if we add them up and it's above 90, then we know we're going south. So then we're going to switch it. We're going to subtract from 90 to get our bearing going south. Good. That's how we know. But if it's less than 90, we're good to go. All right. Let's see. 89, is that right? 89.1. So northeast is what we're looking at. Okay, last one. Dun, 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 dun. When is the dance? When is the dance anyways? After school or in the evening? 4 to 6. Okay.
Yeah, I know, but
Because you have to do it outside. It's like, oh, okay.
That makes sense. It's a brain. I was like,
All right, well, we got the swing problem. Okay, so we have little Danny, and then sister Stacy, and Stacy's a good sister. No?
No.
anything else you have done except for that she's in the swing. So maybe she's a really bad sister.
Yeah.
And we just.
Don't know.
She could be like psychologically abusive.
Yeah.
Holding Danny, like, are we gonna
She
go?
pushes her brother on the swing every minute of every day, and they never stop.
Yeah, he's like, please, I want to get off. And she's like, no.
No.
Stay on the swing.
I must get my equilibrium point. Okay. Stacy pulling through a 45-degree angle now instead of a 30. I think it was 30 originally here. And then holds it at static equilibrium. Danny, you gonna go? Nope, not gonna let you. You can go. No, not gonna let you.
Yeah, poor Danny never actually gets to swing.
Okay, time to go home.
Yeah, exactly. That's all they do.
Okay, so we have the H, the horizontal force. We have the tension on the string force, all right? And then we have the weight of Danny on the ground. There's our three different forces. If they're in static equilibrium, we should be able to make a triangle out of it, right? And so we take the horizontal force, doesn't really matter which direction you go. Take the horizontal force first, tail to head and head to tail here. So the tension on the rope. And then we have our the weight of Danny, and that should form a triangle that we have here. Okay, and then all we know is this guy is still 45 degrees right there. Should be even easier here. Okay, what do we know? The only thing we know is Danny's weight. Danny's weight is 40, he's 42 pounds. Not degrees. Okay, so now talk to me. What can we do? Anybody know this? Well, before I do that, sorry. Anybody know the trick here? And I'm going to say it's a 45 degree triangle. What's so special about a 45 then triangle?
It's on the sides, but I don't remember how. It's two of the sides are equal.
Yeah, two of the sides are equal because this guy has to also be a 45 degree angle, right?
And then the last one is one of the sides times the square root of 2. Is that
Perfect,
right?
yeah,
Right,
uh-huh.
okay, yeah.
That's cool. Good, Grant? Yeah, so this is 42. Awesome, that's 42. Don't even need to do trigonometry, bless you. If you want to, you can. If we needed to, we could. So let's see, just real quick here, just for notation purposes. So I'm looking at this angle here, because I know that's 45 degrees now as well. I'm gonna go this way, 42, and then I don't know what H is. So let me just set up just so you guys can see the notation here. Opposite, adjacent, so I'm gonna use tangent. Tangent of 45 degrees is equal to, and I have to put those in bars in. They're not absolute value. That does not mean absolute value. It just means magnitude of your vector and the magnitude of the H vector. So as you plug it in, we know that guy to be 42, and we're just trying to figure out what in the world is that right there. And so see if we can do this in one step. We did it in 2 steps last time. In your mind, you're going to multiply both sides by H, or magnitude of H on both sides, and you're going to divide by tangent of 45 on both sides. So are you guys okay doing this in your mind? 42 still stays here. These two switch. Are we good there? Cool. Just quick raising hand, how many is not okay with that? No way, I don't think so. Okay. All right, tangent of 45 degrees is just a big old 1. We good? If you want to, you can click on your calculator just to make sure, but tangent of 45 degrees will always just be 1. That's why that makes it true. And this guy is in pounds. So the horizontal vector is 42 pounds. Okay, we'll do the shortcut in the long way here. Adrian said that all we got to do for a 45, 45, 90 triangle is just to take the side that we know, multiply it times root 2, and we get our horizontal. We good out of it? That's it right there. Perfect. Let's do the long way just real quickly here. Still looking at this angle right here. I'm going to use the W that we know, or that was given. So that's opposite, and that's hypotenuse. So opposite, hypotenuse, that's sine. Sine of 45 degrees is equal to opposite. And that's the tension on the rope now. How much tension is needed on the rope? Okay, do the same thing here. Can we... 42 pounds. Tension on the rope is here. And we're going to switch the two, right? Multiply by magnitude of T divided by sine. Anybody give me the calculator answer to it? Sorry, 45. I'll go with that. Are we okay with that? Did you?
Oh, wait, I did. Yeah, I did sine 42.
Okay. No problem. That's what we check it here. What is it again? 60.
Is it 59.4?
Okay, 59.4. Second. Okay, cool. All right. Are we good with homework? Yes, finally done. Okay, so a couple more things here with a little bit of class that we have left. Let me jump to this. And so on your Trig calendar, on your, you guys been looking at this? How many have been looking at this here for the calendar? Awesome. Okay, so I try to update this here, especially when we're thinking through. So I figured I'll just do this. I'm going to add a few more things to this calendar just to keep me what I need to do, and then I can go over that. So today is the 6th. It's chapter 2. And then on the bottom, it kind of just, it says homework review. It says T1 or test 1. I'm going to give it back to you. We good? On the 9th, we come in to take test 2. On Wednesday, it says T1 due. Test 1 due. What? We're going to go over test 1, and I'm going to hand back test 2, and then we're going to go over test 2 on the 13th. What in the world? So I figured this would be like a catch-up week for everything. So take a test on Monday. On Wednesday, real quick, just to explain here. So we're going to go over test 1. I'm going to hand it back to you today. So you have 4 points would be full credit per problem. 3 points means you just missed a little something. 2 points means that it was messed up. 1 point means you were talking about what you're going to do 25 years from now and what happened on Saturday. It was not related to the problem. We good? The 0 is you did not put anything down. We're good? So there's your little point system. Okay, so I hand it back to you. You have until Wednesday to give it back to me. And you can get 1 point per problem if you correct it. We're good? What you have to do to correct it is you have to give me a sentence. What in the world you did wrong? We're good? I used the sine formula when I should have used the cosine formula. We're good? Or I took the reciprocal of my answer as opposed to taking the answer itself. Right? So give me a sentence. What? So tell me what you did wrong. And then you have to do the correct work. And if it's correct, because it's not automatic, but if it's correct, then you get the extra point. So your 3s can become 4s. We good? Your 2s could become 3s, which will help you out a little bit here, okay? And so on and so forth. Your 1s can become 2 and 0. I do want to say, real quick, because the rest of the group is here, as far as homework, as far as the test is concerned, you guys did really good. I'm surprised. You guys actually surprised me. So on the first test, hopefully you guys surprised me on the second. No, a good surprise. But you guys did really good. Lots of 4s on there. There's a few 3s expected.
Guys would do good.
So it really surprised me how.
I never would guess this guy.
Okay, I did not put a percentage on here. So what I did is I kind of did this.
Well, I'm like.
Whatever your score is right here, it's for, let's see, for honors, it was out of 56, we good? For canon students, it was out of 44, so 11 and 13. So look at that, I did not put a percentage yet, because you can still make up a few points, right? And then I'll put a percentage in Google Classroom. Okay, are we good? Is there anything else? Study guide for the exam, you guys all good at? You guys are ready for the test sort of thing? Yeah.
Whoa.
Will be by Monday, okay, that's right. Okay, so let me have that test, and you're good to go here. For right now?
Oh, eyeball. Oh.
Is that right?
Wait. Oh,
Grant.
I really hope we show our.
Grace.
You're like,
Georgia.
you're like,
Matthias.
I guess I'm not. But you say here,
Hayden.
well, kids, well, get back through work.
Catherine George. All right. Nicholas. All right, these are scanned copies, right? These are the ones you guys sent me. Rylan and Haley, this should be yours by default. Yeah. Rylan, for you. There you go. Okay. Okay. Are we good?